Okay, lecture 28 is going to be on exponential functions. This is going to be a pretty quick lesson with our exponential functions. Basically, the whole thing is going to be on graphing these exponential functions. So starting out with, we've got your laws of exponents over here. We've already covered this back in exam 1. If you've got a to the s times a to the t, you would add the exponents, you multiply them here. The s goes to everything on the inside. We've already talked about those, so I'm just going to put those up there. We'll skip that. An exponential function has a standard form. The standard form is f of x equals b times a to the x power. Okay, now that a value there is going to be very, very important for us for today, because that a value is what we're going to call the base. Okay, so anytime I refer to the base, I'm going to be referring to the a value. Okay, now with that being said, this b value here, when we start doing our word problems, that's going to come more into play. That b value is actually our start value there. But for now, that b value, we did not have that when you guys did these back in Algebra 2, so that's going to be an added thing that we will do with shifts and such. Okay. Important things that you should know about the base. Okay, it says that our a value here, a must be greater than 0 and a cannot equal 1. Okay, so your a value can be between 0 and 1, and numbers between 0 and 1 would be 1/2, 1/3, 1/4, 2/3, 4/5. Any proper fraction, okay, can be a base. When we have a base with a proper fraction, the exponential function will look like this. Okay. Shouldn't have drawn the tail that long, sorry. Will look like this. And then you can have a base of any number greater than 1. So 1, 2, 3, or sorry, greater than 1. Couldn't be 1, my bad. Could be 2, 3, 4, 5, and so on, okay? And those exponential functions end up looking at this, okay? So depending on what your base is, if it's a proper fraction or if it's a number that's greater than 1, all it does is it just kind of flips that function for us. You guys will see that when we get into these getting ready to graph them, okay? So let's go ahead and go over graphing a parent function here, okay? I need to graph y equals 3 to the x power, okay? Y equals 3 to the x power. Okay, as with any function, when we get ready to graph this, we're going to start with a table. We're going to put our normal x values there, and we're going to see what we get. Okay, so first one, I'm going to do y equals 3 to the, let's start out with an easy one, 0 power. Well, anything to the 0 power would give me a 1. So 0 and 1, I've got a point 0, 1 on this graph. Okay, next one, another easy one. Let's do 3 to the first power. What is 3 to the first power? Well, anything to the first power is itself, so 3 to the first power would give me 3. So 1, 3 is a point that is on this graph. Okay, next, I've got 3 squared. Again, not too difficult. What is 3 squared? Well, 3 squared is 9. So 2, 9 is going to be on this graph. Okay, and then our negatives. Well, remember, negative exponents. What do negative exponents cause things to do? What's going to make them change sides? So if this is a 3 to the negative first power, that's going to move to the bottom and make that a 1 over 3 to the first power, which 3 to the first power is just a 3. So negative 1 gives me 1/3. So negative 1, 1/3. Okay, got a point there. And last one we got is negative 2. Now this is going to follow a similar pattern because it is to a negative exponent. Negative exponents make it move down. So 1 over 3 squared. Well, 3 squared is 9. So negative 1/9 is going to be on this graph as well. Okay, so we've got these 5 points. So we can see it's coming down here, right? But then as it starts getting to this line, it starts getting close, and it is not going to cross that. Okay, so if you guys start seeing a function getting close to something, I know we just talked about that it can cross the horizontal asymptote, but this one is not. It's going to get close to it. Since it's trending towards that number, that means that we do have an asymptote here, and this is a horizontal asymptote. Okay, So that's kind of our first example of an exponential function that we're just kind of exploring. Y equals 3 to the x power. This is what we got here. So some things that we should probably notice. What are some points on there? We've got the point 1, 3. 3. Okay, we've got the point 1, 0. Okay, nothing really crazy there that I see. And then I've got the point -1, 1/3. And again, So it's almost like that base is going to end up telling us something. And that is correct. A summary of your exponential function. So f of x equals a to the x power. A, remember, is our base. Is going to result in giving us 3 points. Your 3 points is going to be 0, 1. So if I'm looking at that one there, 0, 1, that's on every graph. Every exponential function will have the point 0, 1. Okay? Then I have 1a. Where does that a come from? Well, that would be my base right there. And then I have a -1. Whoops, there's a typo there. I have a -1 and a 1 over a. Again, where does the a come from? Well, it's that base right there. So last year, what I told you guys to do, and I would draw this on here as well, you're going to make a chart every time you want to graph one of these parent functions. I'm going to have x and y. The x's that I will always use these points, -1, 0, and 1. Okay? And here's our rules for each of these problems there. 0 is always a 1. So no matter what, you're going to have 0, 1 on there, always. 1 will always go with your base. Okay? Whatever my base is here, it's going to be paired up with 1. And then the last one, -1. Well, it's 1 over a. Okay, so that a is moved down to the bottom. We could say that -1 always goes with the reciprocal of the base. -1 always goes with the reciprocal of the base. And this, oh no, I did not know I could do that. I hope that didn't damage the video. This right here is what you guys need to have memorized. You will use this to find all 3 of the points every time you graph a parent function. And then, of course, don't forget your asymptote. We don't want to forget our horizontal asymptote, which we'll be running through right here. Okay, so let's practice graphing a couple of these parent functions. So I've got y equals 1/2 to the x. Y equals 1/2 to the x power. So first off, what is our base here? Well, 1/2 would be considered my base. Okay, so I'm going to start with my chart. I've already got it made out. X's are -1, 0, and 1. Okay, so -1, 0, and 1. Start with 0 because 0 always goes with 1, no matter what. 0 always goes with 1. 1 always goes with the base. So 1's going to go with that 1/2 up there. So 1 and 1/2 go together. And then -1, again, dealing with the base, but it's going to be the reciprocal of that base. So we're going to flip this fraction. Well, that's going to make that a 2 over 1, and a 2 over 1 is 2. So my 2 points, or my 3 points that I'm going to have on this are -2, 1. Sorry, say that backwards. -1, 2, 0, 1, and 1, 1/2. And then, along with those points, I need to make sure that I have my asymptote. Okay, have my asymptote. And then I'm just going to draw. So if you guys remember, I told you guys that if it was a fraction here in the base, it just kind of flipped it. So it's the same shape, but it's just flipped the other way. Okay. Next page here, a couple parent functions. Pause the video. Start out by drawing your charts. X and Y, -1, 0, and 1. I want you guys to fill and graph these 2 functions for me. Pause the video and try that. Okay. 0 in this case will always go with 1. 1 always goes with the base, which is 4. And -1 goes with the reciprocal, 1/4. Okay? So I've got 0, 1. I've got 1, 4. I've got -1, 1/4. Get that as close as you can to where 1/4 would be. I'm not going to count that wrong if it's a little off. There's an example of that function here. Okay, draw a table on the other side as well. X and Y. -1, 0, and 1. 0 always goes with 1. 1 will go with the base. This time my base is 1/4. -1 will go with the reciprocal. So I'm going to flip that 4 over 1. Gives me -1 and 4. So here's just another example of how a fraction changes it. Still going to be the same general shape. I don't want to forget my asymptote. And there we go. Okay, so two examples of parent functions. One's with a whole number, one's with a fraction.